Today's topic is vector addition. We're going to kind of look at putting together a lot of the skills that we've been building in terms of these right triangles and that sort of thing. So these end up being pretty big problems. We're going to have multiple vectors for each of these. The whole idea here being that we keep the x and y components separate from each other. And I'll show you that with the example. But we never want to combine x and y's together. We're only going to add x's, and then we'll add y's together separately. And then that's going to give us basically the information that we need to solve our final triangle using those totals. So we'll still use sine, cosine, tangent, still going to use some Pythagorean theorem, but ultimately these kind of end up putting together a lot of little steps. Don't forget, as we're sketching these, you're still going to use your tip to tail technique that we've been using to draw these guys out. So we're going to jump in. I'm going to show you an example. And hopefully that'll help kind of clarify what these problems look like. First step is to read, draw out the vectors like we've been doing. So drawing these things out, read and see what we've got. We've got the first step, 25 kilometers north. So we're going to draw graphical representation of that. We got 25.0 kilometers, and notice I pointed that north. Then turns and goes 12 kilometers to the east. So 12 kilometers to the east, and then turns and goes 25 degrees north of east. So this one's a little bit more complicated because it's got an angle involved here, and so we're going to have to make sure that we get this on our diagram as well. So 25 degrees north of the east line, puts that right here, and that's an additional 14.0 kilometers. Okay, so there's the rough sketch. We're going to go kind of vector by vector and look at these. You're going to find out as you work these problems that any of the vectors that go completely in one direction without having an angle are the easiest to deal with. Like this one just goes north. This one just goes to the east. This one up here is a little bit more complicated because it's at an angle. And because it's at an angle, it has part of it that goes to the east, and then it's got part that goes to the north here as well. So I usually come through and I label these things, and I do so based on which vector it is. So I call this vector 1, vector 2, and then vector 3. And so I label the x and y components. This guy here, because it's just north, this is just a y component. So I label that y1. There is no x component to this because it's just a vertical line. This second vector here is a horizontal line. It just goes to the east, and so since it's the second vector, I like to label this one. It's an x because it's horizontal, and I call this x2. You can call this whatever you want. Some people like to call this x1 since it's the first x. I let the numbers represent which vector I'm talking about. That kind of helps keep me organized. And then over here, this is our third vector, and this one's got both an x and a y component, so I call this one x3. And then I call this y3. So you can come up with your own naming system, but that kind of helps keep things organized as we move forward in the problem. The next thing to do is to solve the values for these. So I come over here and I write, okay, I got x1, y1. I got x2, y2, and x3, y3. I just get set up. So this is for vector 1, this is for vector 2, and this is for vector 3. And I'm going to write values in for each of these. Set up. So vector 1, which was this one, the first one we drew, it only has a y component. It's all the y, so 25.0 kilometers. There's no x component to this, so I'm just going to put a 0 there. Same thing here basically with the x part for number 2. So this is vector 2. It's only an x because it's only a horizontal line, so that 12 kilometers goes here. And there is no y component to this because it doesn't move vertically at all. And then over here, a little bit more complicated. This third vector, which is this guy, has both an x and a y component that we're going to have to solve out. And so to solve the x, I'm going to use cosine. And to solve the y, I'm going to use sine. So just like we have been doing to set those up. So we'll go ahead and write these out. x3, I'm going to put cosine 25 equals x3 over 14.0. And then for y3 over here, we're going to use sine, since that's the opposite side. I'm going to go sine 25 equals y3 over 14.0, and I'm going to get some values. So let me run those through. So for this guy, sticking with, looks like everything's 3 sig, so I'm going to keep 12.7, point in there, kilometers, and that x. And for the y component, looks like that one's going to be 5.92 kilometers. So once you get all of these broken down, then the next step is actually the vector addition part. So we're going to take, I'm going to call x total and y total, and we're just going to add these up. So any of the x's that have a value, I'm going to put here. We got 0, we got 12.0, and we got an x value here of 12.7. The y's, we've got 25.0 plus 0 plus 5.92. So we're going to total these up. X total here, we're going to get 24.7 kilometers. And for our y total down here, we're going to add that up, and we're going to get 30.9 kilometers. So now that we have x and y totals, basically what we're trying to solve is overall displacement. And in this problem, we go from starting point here to ending point, which is up here. So really what we're solving, I'm going to draw a black line through here, is that line right there. And so to do that, we're going to draw what I call the final triangle. And there's a couple different ways to do that. One would be for us to draw the triangle like this. So this is going to be the black final triangle here. You guys can see that right triangle that I drew in. And then all we need to do is put our y total on this side and our x total on this side and solve it. Or we could have drawn that triangle. I'll use pink for this one. We could have drawn it like this and kind of avoided some of the complicating factors up here with all this stuff written. Either of those will work. You can see that the angle descriptions will be different, but ultimately either of those will allow us to solve for that hypotenuse. And so I'm going to go ahead and just use this pink one since it's going to be easier for us to access. And I'm going to put our x total here. And I'm going to put the y total over here. And then I'm going to solve using Pythagorean theorem. Squared and square root. So this is part of the final answer now. Just typing this in. And I'm getting a value of, let's see, keeping 3 sigs, we're going to keep 39.6 kilometers. So that's part of it. That's the overall displacement from start to finish. Using these two numbers, solve this hypotenuse right here in the middle. And then I need an angle and a description of that angle. So I'm going to solve that guy right there. And because I know opposite and adjacent, I'm going to use tangent to solve that. So I'm going to go tan theta equals opposite over adjacent. Right, we'll have to use the inverse tangent on your calculator to solve this one out. Inverse tangent, all right, that's coming out to be 24.7. Tangent. I am coming up with an angle of 51.4 degrees. And that angle description is from the east line, and we go north of there. So this is going to be north of east. And so this whole thing becomes our final answer. Lots of little steps, lots of little places to make mistakes. Really helps to stay organized. So come up with some kind of system, even if it's not exactly the way that I did it, to keep all of your numbers and information organized.